Welcome to Section 3, Programming AWS Lambda with C#. At the time of recording, C# is the newest language addition to the AWS platform. You can now build Lambda functions and serverless applications using C# and .NET tools. In this section, we are going to take a look at creating Lambda functions and serverless projects using the .NET Core platform and Visual Studio. In the first video, we are going to create a Lambda function using .NET Core. In this video, we are going to take a look at how to install the AWS Toolkit for Visual Studio. Then we are going to try out some features of the AWS Toolkit and we'll use it to create our first C# Lambda function. As a first step, we are going on to the AWS website to download the AWS Toolkit for Visual Studio. Execute the installer. Now we're done installing the toolkit and I'm going to launch Visual Studio 2015. After you have signed up for an AWS account, sign into the Management Console. I'm going to show you how to navigate the Management Console in one of our next videos. For now, just click on Services in the upper left-hand corner and select IAM. Click on IAM to navigate to the Identity and Access Management dashboard. Here I'm going to create a special user with permissions to access AWS services programmatically. And this allows me to set up my local development environment in a way so that IDEs, development frameworks, can use AWS on my behalf. And you should set up an IAM user to keep your AWS account secure, because you can simply create an IAM user with a set of permissions, and after performing the exercises using that IAM user, you can later delete it. Thereby, your access credentials are not prone to the risk of being abused by somebody else if another person gets access to your identity and access. So now I'm on the Identity and Access Management dashboard. And here I'm going to create a special user for the purpose of this tutorial. I'm going to give this user access permissions to my AWS services to use them programmatically. And it's always a good practice to create an IAM user with special tailored permissions. And for the purpose of this tutorial, I'm going to create a user to access AWS services on my behalf, for example, through the Eclipse IDE or through the serverless framework. After you have performed the exercises of this video tutorial, you can simply delete this IAM user, and thereby you don't run the risk to accidentally expose your credentials so that somebody else can use your AWS account on your behalf. First, I'm going to create an IAM group. So click on Groups on the left-hand side. Create a new group, and I call it Learning Group. I call the new group Learning Group, and I click on Next Step. For simplicity, I give my group administrator access. So this is not the best security guideline, but it's simple and gets us started quickly. You can and you should probably delete this group as soon as you are done with performing these exercises. Click on Next Step. Now create the group. I'm back on my dashboard and now I'm going to create a user and assign the user to my newly created group. I clicked on the Add User button and now I'm giving my user the name Learning Lambda. I give my user programmatic access. This will create an access key ID and a secret access key for my user. So thereby my command line interface, the serverless framework, SDKs or other development tools that I set up on my local computer can access AWS services on my behalf. Next, click on the Next Permissions button. I have added my user to the group Learning Group, and now I'm going to create the user. Yay, our user has been created successfully, and here is the access key ID and the secret access key of my user. Copy this information into a text editor because we need it in the next step. Let's get started by creating a new AWS Lambda project. Click on File, New, Project. And after installing the AWS Toolkit, you should see the following options on the left-hand side, saying AWS Lambda, and here are some sample projects with sample code for your reference. Let's get started with a very simple AWS Lambda project using the .NET Core framework. I'll leave the defaults as they are, AWS Lambda 1, and click OK. Here I'm going to select one of the blueprints. Let's get started with a really simple empty function blueprint and click Finish. Our AWS Lambda project has been created and it shows up in our Solution Explorer. Let's take a look at the function handler. So the structure of this Lambda function looks similar to the examples that we have seen before with Java and other programming languages. Here we have our function handler, and the function handler takes two arguments, the input, which in this case is a string, and the context object, which gives us information on the runtime context of our Lambda function. What this Lambda function does is it simply takes the input, transforms it into uppercase characters, and returns them. Also make sure that you are in the right region. We want to deploy our Lambda function into the EU Central region in Frankfurt. Give our function the name CS function and click Next. Here we can select some further configurations for our Lambda function, such as an IAM role. For example, if from within your Lambda function you want to access other AWS services, you need to select an IAM role that gives your Lambda function permission to do that. Here we can also configure the amount of memory. Let's select the smallest amount and the timeout after which our Lambda function will time out. As IAM role, I simply choose the Lambda basic execution role, which has no special permissions. Okay, let's upload our Lambda function. We have created our first Lambda function with C#. Now let's invoke it. Since we haven't given it any input, we retrieve an error. Let's give it some input. And invoke again, and as a response we get our uppercase string as return. Here you can also see the log output. As a last step, let's head to our AWS Management Console and have a look at our Lambda function there. On the AWS Lambda dashboard, you can see that 4 functions have been created. For getting all blocks, for getting a single block, for adding a block, and for removing a block. Let's check out our DynamoDB dashboard. Here a new table has been created, CS block table. It has a single hash ID or primary partition key with name ID and of type string. Okay, everything looks good. Let's try out our API by invoking it with Postman. First I go back to Visual Studio. I'm logged into my AWS Management Console. I'm in the Frankfurt region where I have deployed all my functions, and as you can see we have a new addition, the CS function. We can take a look at it by clicking on Monitoring, and as we can see we just had an error and we also had one successful invocation. If you click on CloudWatch, you can also view the logs there that you have just seen in your Visual Studio log console. In our next video, we are going to create a serverless application with C# and the .NET Core framework.